This LOS is distinguished between dependent and independent events. Dependent events, knowing the outcome of one tells you something about the probability of the other. Independent events, occurrence of one event does not influence the occurrence of the other. For the joint probability of independent events, just multiply. So for example, flipping a coin, the probability of heads is 50%. So the probability of 3 heads in succession is simply 0.5 times 0.5 times 0.5 equals 0.125, or 12.5% probability of getting 3 heads in a row. Two events are independent if the occurrence of one event does not affect the probability of occurrence of the other event. Two events A and B are independent if and only if the probability of event A given that B has occurred equals the probability of A, or equivalently, the probability of event B given that event A has occurred equals the probability of B. When two events are independent, the joint probability of A and B equals the product of the individual probabilities. So we're just using the multiplication. Therefore, if we're interested in two independent events with a probability of 0.25 and 0.5 respectively, the probability that both will occur is 12.5%, 0.25 times 0.5. The multiplication rule for independent events generalizes to more than two events. For example, if A, B, and C are independent events, then the probability of A, B, and C all happening is the probability of A times the probability of B times the probability of C. And we've seen that before in previous LOS, seeing you've got 100 stocks and you've got 3 screens. What's the probability that a stock will go through all 3 screens? We multiplied the probabilities. Okay, we're going to end the video for this LOS with one last practice question. If two events A and B are independent and the probability of A does not equal the probability of B, i.e. the probability of A doesn't equal B, then the probability of event A given that the event B has occurred is best described as A, the probability of A, B, the probability of B, or C, the probability of B given that A has occurred. Okay, this was a pretty easy question if you remember sort of the formatting and the nomenclature. So A is correct. Two events A and B are independent if and only if the probability of event A given that event B has occurred equals the probability of A. So that's what the question was asking. So with that, that's the last slide for this LOS. Thank you very much.